Welcome everyone. Today we begin an exciting 62-day journey into the world of low-level design. Over the coming weeks, we are going to transform the way we think about software. We will shift from writing code instinctively to designing systems intentionally. Our goal is simple yet powerful. Think like system architects, build like engineers, and create software that scales beautifully. This course is not just about patterns or diagrams, it is about developing a structured engineering mindset. So let us commit to learning deeply, applying every concept, and growing into confident system designers together. Today we start with the foundation, understanding what low-level design really is and why it matters. We will explore the meaning and purpose of LLD, the difference between HLD and LLD, why LLD plays such a critical role in real-world software, key design principles we will follow throughout the course, the mindset of a true system designer, tools and methods we will use, and finally, a small hands-on exercise and our assignment. By the end of today, we will have built the mental model that will guide us for the next 62 days. Low-level design is where ideas transform into structure. It bridges the gap between requirements and working code. When we do LLD, we break a feature into logical components, identify classes, objects, and their responsibilities, define attributes, methods, and flows, establish communication between components, apply OOP, solid, and design patterns. Think of LLD as an architectural blueprint at the code level. For example, in an e-commerce system, instead of saying we need checkout, we identify cart, product, user, payment, inventory, and design how they interact before we write any code. This level of clarity makes development faster, cleaner, and more scalable. In software design, there are two key stages, high level design and low level design. High level design is a macro view. We discuss overall architecture, services, databases, and external systems. Low level design is micro view. We define classes, methods, interactions, data flow, and internal logic. HLD decides what the system is made of. LLD explains how each part will work and collaborate. Strong engineers don't just understand code, they understand structure, and LLD builds that structural thinking. Low-level design is essential because it creates scalable systems that handle future growth, maintainable code bases that last years, logical and modular software structure, efficient communication with architects and PMs, confidence in interviews and real-world projects. Most top tech companies evaluate LLD because it reflects real engineering maturity. When we master LLD, we reduce bugs, speed up development, and build software that stands the test of time. When we write code without design, we are gambling. When we design fast, we are engineering. Low-level design is not a theory, it runs the world. Every major platform relies on it. Digital payments like UPI and PayPal, food delivery platforms like Zomato, ride-sharing systems like Uber and Ola, banking and financial systems, e-commerce and booking platforms. Whenever there are connected features, business rules, user flows, or state changes, LLD is involved. Understanding LLD means we can model real-world systems reliably. A strong design has key characteristics. Modular. Each piece handles one purpose. Readable. Clear and easy to understand. Extensible. Easy to add new features. Low coupled and high cohesive. Components only do what they should. Pattern oriented. Uses proven solutions. Testable. Easy to validate and debug. Maintainable, can be improved without breaking things. The golden rule, clarity is more valuable than cleverness. We build systems so that future developers can understand, extend, and trust our work. Before we open an IDE, we think, we analyze requirements, structure concepts, and visualize object interactions. We ask, what are the core entities? What behaviors do they have? How will they interact? Will this design scale? Can this evolve later? Systems are not born inside code editors, they are conceived in our mind first. This mindset separates programmers from engineers. Throughout this course, we will master OOP pillars, the building blocks, solid principles, the foundation of scalability, design patterns, advanced engineering techniques, UML diagrams, visual modeling, clean code and refactoring, professional coding standards, unit testing, ensuring correctness and reliability. We will work with industry tools like Draw.io, Miro, Lucidchart, and VS Code. By the end, we won't just understand LLD, we'll think in LLD. Let's think through a real world design challenge. We want a coffee machine that can prepare different beverages. Ask yourself what are the main components, what objects exist, what is each responsible for. Possible classes include coffee machine, beverage, water tank, inventory, user interface. This simple exercise sharpens our breakdown and modeling skills, a habit we will build every day. Now it's our turn to apply today's learning. We will answer what is low-level design, how does HLD differ from LLD, 5 real-world systems that use LLD, UML diagram for a pen notebook system. We can submit it as images, PDF or Google Doc. This is not homework, this is practice to build our system design muscles. Before we wrap up today, let's pause. What changed in our thinking today? Did we notice that software isn't just code? It's structure, thought, organization, clarity. Reflection anchors learning. We don't want to just attend a session, we want to transform our thinking. Tomorrow we strengthen our OOP fundamentals, encapsulation, inheritance, polymorphism, and abstraction. These aren't just theory terms, they are the backbone of every scalable system. Let's come prepared with our laptops, notebooks, and UML tools because tomorrow we move a level deeper into engineering excellence. This journey is long, but every day will build our mindset, our skills, and our confidence. We are not just learning LLD, we are learning to think like world-class engineers. Today we planted the seeds of design thinking. Systems are conceived in our minds, structured through diagrams, defined by principles, and only then written as code. Tomorrow we build the foundation that powers all great systems, strong OOP design. Let's continue forward with curiosity, discipline, and excitement.